Today, that is 22nd December, India celebrates National Mathematics Day in honor of the birthday of famous mathematician Srinivasa Ramanujan. Wishing you all a very happy National Mathematics Day. It is also a great day for all of us as we are celebrating one successful year of INSpRE Mathematics Club, a club to be inspired. So on this occasion, all the members of INSpRE Mathematics Club are going to pay a tribute to all the great mathematicians by delivering a presentation on their contribution in their respective fields. By the end of this presentation, we hope that we give you a better understanding of their endowment.
Hello everyone. I am Ramsha Beg and I am glad to present on the most important topic, that is Srinivasa Ramanujan on the occasion of his birthday. This presentation is made by me and my colleagues Siddhi Kanavde and Gautami Matre. Srinivasa Ramanujan was an Indian mathematician who lived during the British rule. Though he had almost no formal training in pure mathematics, he made substantial contribution to mathematical analytics, number theory, infinite series and continued fractions. Now let us have a look about his early life and adulthood. In 1903, Ramanujan secured a scholarship from University of Madras, but lost it in the following year because he neglected all the other studies because of his interest in mathematics. In 1909, after his marriage, he began to research for permanent employment that culminated in an interview with a government official, Ramachandra Roy. In 1911, Ramanujan published the first of his papers in Journal of Indian Mathematical Society. Moving on to his contribution, he compiled around 3,900 results consisting of equations and identities, and one of his most treasured findings was his finite series of pi. In 1916, George Andrews discovered Ramanujan's notebook in the library of Trinity College, which were later published as a book. Once in a meeting between Mr. Hardy and Ramanujan, Mr. Hardy equipped that he came in a taxi with the number of 1729, which seems today ordinary, to which Ramanujan replied that it is the sum of cubes of two numbers, 10 and 9, and that's why 1729 is known as Hardy-Ramanujan's number. Now let us have a look at his mathematical achievements. 1 upon pi is equal to 2 root 2 upon 9801 multiplied by the sum from k is equals to 0 to infinity of 4k factorial multiplied by 1103 plus 26,390k all over k factorial to the power 4k multiplied by 396 to the power 4k is known as Ramanujan's pi formula. Ramanujan's series for pi converges extraordinarily rapid and forms the basics of some of the fastest algorithms currently used to calculate pi. Ramanujan fought with his health issues throughout in his life. Since it was difficult for him to follow his strict diet plans requirement for his religion, he was diagnosed with TB and severe vitamin deficiency, and in 1911 he returned to Kumbhakoram Madras residency, India, and passed away at the age of 32 in 1920. Now let us end the presentation by the small thought of Srinivasa Ramanujan. An equation means nothing to me unless it expresses a thought of God. Thank you.
Hello everyone. So these presentations are on Sri Bharti Krishna Tirthaji and R.P. Paranspe, who is also popularly known as Wrangler Paranspe. Let's start with Sri Bharti Krishna Tirthaji. He founded Vedic mathematics by the holiness of Jagadguru. He was born on the year 1884. He also wrote a very popular book called as Vedic Mathematics, which was published in the year 1965. What is Vedic mathematics? It is the world's fastest mental math system. This system is based on 16 sutras, or you can also call it as word formulas. This is the most systematic, simplified and unified system than the conventional system. It also eradicates the math phobia from the student and create a kind of interest towards the subject. It builds and strengthens the math concept. Why it is called Vedic? The word Vedic comes from the word Vedas, which means the fountainhead of all knowledge. The sutras which are used in Vedic mathematics are also found in ancient Vedic texts. According to the Supreme Court of India, Vedic means time factor. Vedic math is secular, which means anyone from anywhere in the world can practice it and take advantage of it. Evidence of Vedic mathematics. Most important sources of Vedic maths are found in astronomy, astrology, and kalpa. These evidence are usually in the form of sutras. It is a peculiar form of writing which is very concise and is often used the poetic style to capture the essence of argument or a result. Scope of Vedic mathematics. It covers a range of topics from arithmetic, algebra, trigonometry, and calculus. Vedic maths is applicable from schools to colleges in entrance exam. It is also applicable in the field of IT. Vedic maths are currently being practiced in the curriculum of South Africa, Onam, UAE, Nigeria, and Ghana, and soon it will be implemented in Singapore and Thailand. Let us discuss one of the methods in Vedic mathematics, which is high-speed multiplication, also called as the base method. The Sanskrit sutras which are used in this method are Nikhilam Navataskarmam Dastaha. It has two important rules, which is we cross add or we cross subtract, and second is we multiply it vertically. So here are some examples of high-speed multiplication. Now let us go with the application of Vedic mathematics. Kalpa Sutra gave direction for conducting sacrificial fires at different times of the year. To calculate planetary motion with Vedic mathematics. We can also use to construct calendars and panchaganas for lunar as well as solar months. So this was it about Sri Bharati Krishna Tirtha Ji Maharaj. Now let's come to the next Indian mathematician, which is Sri Raghunath Purushottam Paranspe. He was the first Indian to achieve the title of Senior Wrangler at the University of Cambridge. Sir Raghunath Purushottam Paranspe was born on 16 February 1876. Wrangler, what does this title actually mean? At the Cambridge University of England, a student who gains the first class honour in the third year of university's undergraduate exam was honoured by the title of Wrangler. The highest scoring student was called Senior Wrangler, and R.P. Paranspe became a Senior Wrangler in the year 1899 by excelling in these exams. Let us discuss the work of Sir Wrangler Paranspe. Sir Wrangler worked as a professor of mathematics at Fergusson College in 1902. In 1907, he became the first librarian of Indian Mathematical Society of Fergusson College. He worked as Educational Minister till 1923 as a part of the hierarchy in Bombay Presidency. He also worked as High Commissioner of India to Australia from 1944 to 1947, pre-independence India from British Raj. Achievement of Sir Wrangler Paranspe. Sir Wrangler was appointed as the first Minister for Education and he served this position till 1923. He also received a knighthood from the colonial government in 1942. In 1921, the University of Calcutta awarded him an honorary Doctorate of Science degree. He was also the founder of Indian Rationalist Association in Chennai in 1949. So this was about Sri Raghunath Paranspe. This presentation was made by Akash Rathod and Punya Srivanshi. We thank you for watching this presentation. Thank you.
Hello everyone. The topic for today's presentation is Shakuntala Devi and Kaprekar constant. This presentation is made by me and my teammate Sriram Sabde. As we all know, Shakuntala Devi is also known as the human computer. So now let us dive into her early life and see how she was. Shakuntala Devi was born on November 4, 1929 at Bangalore, Karnataka. Her father used to work in a circus. When Shakuntala was 3 years old, her father discovered that she had an amazing ability to memorize the numbers. After this discovery, her father left the circus and went down the streets with her to display her ability to the rest of the world. At the age of 6, without any formal education, Shakuntala Devi was presented at the University of Mysore to demonstrate her arithmetic abilities. In 1944, Shakuntala Devi moved out to London with her father. Now that we know about her early life, let us see her arithmetic skills. In 1950, Shakuntala Devi toured Europe to demonstrate her arithmetic skills. In 1976, she also performed at New York. In 1988, Shakuntala Devi visited Professor Arthur Jensen to get her arithmetic abilities tested. Arthur Jensen was a psychology professor at the University of California, Berkeley. In 1990, an article on Shakuntala Devi related to psychology was published. She was able to get the cube root of numbers such as 64,629,875 and the seventh root of number like 170,859,374 in no time. Moving towards her achievement. In the year 1969, at University of Philippines, Shakuntala Devi was awarded the award of Most Distinguished Woman of the Year. In 1980, at Washington, D.C., Shakuntala Devi was awarded with the Ramanujan Mathematical Award. In year 2013, Shakuntala Devi was awarded with the Lifetime Achievement Award at Mumbai. In year 1977, at the Southern Methodist University in Dallas, USA, she was able to get the 23rd root of 201 digit number. The speciality of this event is that the time taken by the professor to write down this number was 4 minutes, and the computer Univac, with a special algorithm created for calculation, could not defeat Shakuntala Devi. The time recorded by Shakuntala Devi is 50 seconds, whereas the computer took more than a minute to get the answer. On 18 June 1980, at Imperial College London, Shakuntala Devi calculated the multiplication of two 13-digit numbers. The numbers were chosen at random by the professors. The time recorded for this calculation by Shakuntala Devi is 28 seconds. This achievement is recorded in 1982 edition of Guinness Book of World Records with the title Fastest Human Computation. Moving towards her contribution, she has contributed with writings. She was a writer and an astrologer. She has written books related to mathematics, calculations, social issues, puzzles, and mysteries. Some of her books are mentioned in this slide. Her death and legacy. On April 21, 2013, Shakuntala Devi died at the age of 83 due to several respiratory problems. On November 4, 2013, she was honored with a Google Doodle on the day which was meant to be her 84th birthday. The film on her life, titled Shakuntala Devi, was announced in May 2019. Moving forward towards D.R. Kaprekar. D.R. Kaprekar, also known as Dattatreya Ramchandra Kaprekar, is an Indian recreational mathematician who has described several classes of natural numbers like Kaprekar, Harshad, and self-number. He has also found the Kaprekar's constant named after him, 6174, also known as the Kaprekar's constant and the magical number. So what is Kaprekar's constant? Kaprekar's constant is a number which arises when we take a 4-digit number and rearrange its digits in such a manner that we get a largest and the smallest number out of it. After this rearrangement, we subtract these digits. After subtraction, we get this magical number. If the value obtained is not equal to the Kaprekar's constant, we again rearrange this value into a largest number and the smallest number and subtract it. The iterative process is known as the Kaprekar's routine, which goes on until we get the Kaprekar's constant. So let us know more about Kaprekar's constant with the help of an illustration. In this example, we have taken a 4-digit number, that is 3215. Here, we have rearranged the numbers and subtracted it. Since the answer found is not equal to the Kaprekar's constant, the value goes on Kaprekar's routine until it reaches the 7th step where we obtain the Kaprekar's constant. Some important observation of the number are that the number when divided by the sum of its digits gives us 343 as the answer, and the most steps required to reach the Kaprekar's constant are 7. This number is also obtained with 3-digit numbers and 5-digit numbers. However, in 5-digit numbers, we get a repetitive answer instead of a single convergent integer value. Python code to find the Kapleker's constant. Following is the Python code which is used to get the Kapleker's constant as an answer for any 4-digit number. Here we have inputted three numbers, that is 1000, 1112, 9812. The answer we get in return is Kapleker's constant. Here I conclude with my presentation. Hope you enjoyed it. Thank you.
Hello everyone. Moving on to the next presentation talking about the father of Indian statistics, P.C. Mahalanobis, which will be presented by my teammate Sahana Kumbar and myself Ramsha Beg. Prasanta Chandra Mahalanobis belonged to a family of Bengali landed gentry who lived in Bikrampur, now in Bangladesh. Mahalanobis received his early schooling at the Brahmo Boys' School in Calcutta and completed his graduation in 1908. He joined the Presidency College, then affiliated with the University of Calcutta. Mahalanobis received a Bachelor's of Science degree with honours in physics in 1912. He left for England in 1913 to join the University of London. Professor Prasanta Chandra Mahalanobis was born on 29th June 1893 and his birth anniversary is celebrated as National Statistics Day. He was the founder of Indian Statistical Institute (ISI) and contributed to the design of large-scale sample surveys. And for his numerous contributions, Mahalanobis has been considered as the father of modern statistics in India.
P.C. Mahalanobis is best remembered for the Mahalanobis distance, a statistical measure, and for being one of the members of the first Planning Commission of India. The formula is used to find the distance between a point and a distribution based on the measurements in multiple dimensions. It is widely used in the field of cluster analysis and classification. D square is equal to x minus m raised to p c raised to minus 1 into x minus 1, where d square is the square of the Mahalanobis distance, x is the vector of observation, m is the vector of mean values of independent variables, and c raised to minus 1 is the inverse covariance matrix of independent variables. Mahalanobis distance is an effective multivariate distance metric that measures the distance between a point and a distribution. It is an extremely useful metric having excellent application in multivariate anomaly detection, classification on highly imbalanced data sets, and one-class classification. Indian Statistical Institute (ISI) is higher education and research institute. Since 1915, P.C. Mahalanobis taught physics at Presidency College, but his interest in statistics grew under the guidance of Polymath Brajendranath Seal. Many colleagues of Mahalanobis took an interest in statistics, and the group grew in the statistical laboratory. This group, particularly Mahalanobis and his younger colleagues S.S. Bose and H.C. Sinha, felt the necessity of forming a specialized institute to facilitate research and learning of statistics. On 17 December 1931, a meeting was held which led to the establishment of the Indian Statistical Institute, which was formally registered on 28 April 1932 as a non-profit distributing learned society under the Societies Registration Act 21 of 1860.
The Bangalore Center of Indian Statistical Institute was conceived by P.C. Mahalanobis during 1962, even when the city was emerging as the center of science. The Delhi Center of Indian Statistical Institute was started in 1974 and shifted to its present campus in 1975. The Northeast Center of ISI at Tezpur was inaugurated on July 23, 2011 by Sri Pranab Mukherjee, Honorable Union Finance Minister and Chairman of ISI Council.
Achievements of P.C. Mahalanobis.
He was the Fellowship of the Royal Society in 1945. He received the Weldon Memorial Prize from the University of Oxford in 1944. Even he was awarded by the Padma Vibhushan in 1968 and also by the Srinivasa Ramanujan Gold Medal in 1968. Now, let us end our presentation with a small quote by P.C. Mahalanobis. A research genre serves that narrow border land which separates the known from the unknown. Thank you.
Hello everyone, so now we'll have a look on mathematical achievements of Indians in 2021. First is Nikhil Srivastava. He jointly won 2021 Michael and Sheila held prize along with two others for solving long-standing questions on Kedison-Singer problem and on Ramanujan graphs. And second is Neena Gupta. She recently won DST ISTP IMU Ramanujan Prize for Young Mathematician from Developing Countries. We congratulate them from our side. Thank you. So now, on behalf of INSpRE Club and faculty, I would like to thank you all for patiently listening, and I would also like to extend my vote of thanks to the members of INSpRE Club for sharing information about the Indian mathematician with everyone, and let us all keep their great works in our mind. No doubt we will further continue organizing more such interesting events with you guys. And we also have an Instagram handle which is @INSpRE Club. To know more about us, the link is in the description below. Thank you for your kind attention and I hope you have a good day.